Solving an equation is probably one of the most important operations that you're going to be doing during this whole course. So it's worth learning to do them properly and learning to do them well. When you're solving an equation, what you're trying to do is you're trying to find a value of x which makes the equation work. What value of x would you fit in here to make it work? Now, some of these are very easy and you'll be able to guess the answer and see it straight off. But even though that's pretty clever of you to do that, it's not going to help you get harder questions out, so we need a method of doing it. There's an analogy at the top of the page where there's a set of balance pans, and we're talking about how if the balance pans are in balance, then as long as you do the same thing to one side of the balance pans as you also do to the other side, they'll remain in balance. Now that's exactly what we're doing here, because it's in balance to start off with. It's got an equal sign in it. This equals that. So if whatever we do to this, we also do to that, it'll remain in balance, and that's what we do. At the moment it's x plus 3. If I was to take away 3 from that side of the equation, as long as I also take away 3 from this side of the equation, it'll remain in balance. Now the reason I'm taking away 3 from this side is to get x by itself. I want to end up getting x equals something, and I can see that if I've got x plus 3 and I also take away 3 from that side, that's going to cancel each other out when I come to collect up my terms here. So that means that x plus 3 take away 3 is just equal to x. X equals 5. Now, as I said, you probably guessed that to start off, but what we've got here is a very powerful method which will enable us to solve harder equations. X plus 2 equals 7. So what I really want to do here to get x by itself is to get rid of this 2. And I can do that by doing the opposite thing to plussing 2, which is minusing 2. So if I've got x plus 2, I'll take away 2, that should cancel each other out, but I've also got to take away 2 from this side of the equation, 7 minus 2. After I've collected up the like terms here, I just have x, which is what I want, and if I take away 2 from this side, 7 minus 2 is equal to 5. So there's my value of x that makes it work. I should check my final answer by getting this 5 and seeing what happens if I put it up in here. Does it make it hold true? 5 plus 2 equals 7? Yes, it does. So I've solved the equation. X minus 6 equals 5. What I've got to do is the opposite of minusing 6, and that'll kind of get rid of that operation of taking away 6. If I go x minus 6 and then also plus 6 to that side of the equation, that'll be great because that'll get rid of those 6's, but I also must add 6 to the other side of the equation to keep it in balance. X take 6, add 6 is just equal to x, and 5 plus 6 equals 11. So x equals 11 is the solution to the equation. That's the value of x that makes the equation work. X take 8 equals negative 2. The opposite of taking 8 is adding 8. So if I add 8 to that side of the equation and also add it to this side of the equation remains in balance. And this minus 8 plus 8 kind of cancel each other out when I collect up the like terms. So that means x will equal minus 2 plus 8, which equals 6. That's the value of x that makes the equation hold true. 6 take away 8 does equal negative 2. Here we've got 4x equals 16. Now remember that 4x means 4 times x. So if I want to get rid of that 4 there and just have x by itself, I've got to do the opposite of timesing by 4, which is dividing by 4. Remember this, addition and subtraction are opposite operations. One undoes what the other one does, and multiplication and division are opposite operations. One undoes what the other one does. So if 4 times x, the opposite operation to timesing is dividing. If I was to get both sides and divide them by 4, it's going to remain in balance, and what's more, these 4's are going to cancel each other out. 4x divided by 4 is equal to x. But now we've got 16 divided by 4, and 16 divided by 4 is equal to 4. Put the answer back in there, it will make a true math statement. Here we've got negative 3 times x. The opposite to timesing by minus 3 is dividing by minus 3. If I divide both sides by minus 3, these will cancel each other out, and I'll just be left with x on this side of the equation. But on this side of the equation I'll have negative 12 divided by negative 3, or 12 divided by 3 is 4, and because we've got minus divided by minus, the answer is going to be plus 4. Now this is a bit of a special one. Negative x equals 10. It's worth kind of just memorising the result here. What you're actually doing is you're multiplying each side by minus 1. Minus x times minus 1, minus times a minus will give you a plus x. That's how we get our plus x out of that. But if I times this side by minus 1, I've got to times this by minus 1, and 10 times minus 1 is negative 10. But I think you can see that it makes sense. If you've got negative x equals 10, then x has to equal negative 10. The other thing, of course, when you put this in there instead of x, it will hold true. Minus negative 10 does equal positive 10. So we've got a true math statement. Here we've got x divided by 4 equals 10. And so we've got to do the opposite of dividing by 4, which is timesing by 4. And if I do it to one side, I must also do it to the other side. X divided by 4 times by 4, those 4's cancel, and I'm just left with x equals 10 times 4 is 40. And x divided by 5 equals negative 4. I want to get x by itself, so I want to get rid of this 5. I can do that because the opposite of dividing is timesing. So if I x divided by 5, if I times that by 5, those 5's are going to cancel out, but I must also times the other side by 5. X divided by 5 times by 5, they cancel out, and I have x equals minus 4 times 5 equals negative 20. The answer makes the original equation work. Minus 20 divided by 5 does equal minus 4. These equations take plenty of practice, and as I said when I opened, don't get into the habit of kind of guessing your answer and just writing it down. Try and develop this technique where whatever you're doing to one side of the equation, you also do to the other side of the equation, and then shuffle things around until you end up getting x equals something.